The percent of drug ionization tells you how much of a drug is charged and how much is uncharged at a specific pH. And that single distinction determines whether the drug can cross membranes. And so only the unionized form of drugs moves easily through lipid membranes. So once you calculate the percent of drug ionization, it helps you predict where a drug will be absorbed, whether it can enter the brain, why local anesthetics failed in infected tissues, and how we enhance drug elimination in overdose. And so in this video, I'm going to show you how to calculate the percent of drug ionization using two examples. And we are starting right now. Hello, this is Dr. Danquah, and if this is your first time here and you like to learn pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. So to calculate the percent of drug ionization, there are two equations we want to be familiar with, and the first one is for the situation where you have weak acids, and then the other version is for when you have weak base. So these equations come directly from the Henderson-Hasselbalch equation, but once you memorize this, it's a very elegant and convenient way to do your calculations. And for the weak acids, the equation is percent ionization is equal to 100 divided by 1 plus 10 to the power pKa minus pH. And so this equation is for weak acids, or when your drug is a weak acid. And for the weak base, the equation will be percent ionization is equal to 100 divided by 1 plus 10 to the power pH minus pKa. So the equations look very similar. The difference is what the expression is in the exponent for the 10 raised to the power pKa minus pH for the weak acids. So for the weak acids, it's pKa minus pH, and then for the weak base, it's pH minus pKa. So that's important to just have stenciled in your mind. And so now with these equations, you can actually determine the percent of ionization of a drug. Once you know whether it's a weak acid or a weak base, you choose the appropriate version of the equation, and then you simply do the math associated with that equation. So we're going to look at two examples, one for a weak acid and the other for a weak base. So this question says ibuprofen is a weak acid with a pKa of 4.9. What is the percent ionization of ibuprofen in plasma at physiologic pH 7.4? Round to the nearest whole number. So the key thing here is to recognize that ibuprofen is a weak acid. And so the version of the equation we'll be using is percent ionization is equal to 100 divided by 1 plus 10 to the power pKa minus pH. So you want to memorize this equation. And so now what we can do is simply substitute in the values. So we are going to have 100 divided by 1 plus 10 to the power 4.9 minus 7.4. And that's going to be equal to 100 divided by 1 plus 10 to the negative 2.5. And that's essentially 100 divided by 1 plus 0.00316. And that's going to be equal to 100 divided by 1.00316. And that's equal to 99.7%. And it says round to the nearest whole number. So that's essentially 100% ionized. And so the next question says lidocaine is a weak base with a pKa of 7.9. What is the percent ionization of lidocaine in plasma at pH 8.9? Round to the nearest whole number. Now in this question, lidocaine is a weak base, and so the version of the equation we'll be using is percent ionization is equal to 100 over 1 plus 10 to the power pH minus pKa. And then we substitute in the values. So you're going to have 100 divided by 1 plus 10 to the power 8.9 minus 7.9. which is going to be equal to 100 over 1 plus 10 to the power 1, which is 10. And so you end up having 100 over 11. And now that's going to be equal to approximately 9. It's actually 9.09. But the question says round to the nearest whole number. And so it's going to be 9%. So if you are preparing for an exam, one of the things you can keep in mind is for this type of question, even before you look at the numbers, you want to first determine whether the drug in question is a weak acid or a weak base, and then you make sure that you choose the appropriate formula for the drug that you have. Because if you choose the wrong formula, your math can be perfect, but your answer will still be wrong. So I hope you found this video tutorial useful. If you did, be sure to like it and share it. And if you have any questions, just leave them in the comments and I'll get to them as soon as I see them. If you'd like to learn more pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. Thank you so much for watching, and I'll see you in the next video.